Hi everyone. Hi Afrinkan. Good morning. So this is the QR code of my compiler design book. So this will be helpful for GATE, BTech and MTech. If you have not bought it, buy it from PW store. This is the QR code. Okay. And this is the QR code of my Telegram channel. If you have not joined it, please join the Telegram channel. Okay. And write your answers in the Telegram channel. Right. Scan the QR code and join the Telegram channel. And yesterday we were talking about grammars, right? Yesterday we were talking about grammars, regular grammars. Today also we will see regular grammars. Okay? Tell me about this. What is the language accepted by this? S derives A or B, A derives A or epsilon, B derives B or epsilon. Tell me what is the language accepted by this? Open the Telegram channel, write it in the Telegram channel, okay? Open the Telegram channel. And write it in the Telegram channel, okay? S derives A or B, A derives A or epsilon, B derives B or epsilon. Write your answer in the Telegram channel. Good morning, Rajiv. Write it in a paper and take a picture and post it on Telegram channel, okay? What is the answer? Janardhan, good, but you made a small mistake. Write it in the Telegram channel. So A followed by epsilon or epsilon. Excuse me. This is going to generate A star, and this is going to generate B star, right? So S is generating either A or B, which means A star plus B star, A star plus B star. Okay. Now answer this. S derives A or B. A derives A or epsilon. B derives B followed by A or epsilon. What is the language generated by this? What is the language generated by this? Good morning, Shantanu. So this is a tricky question. You have to analyze it a bit. Okay. This is a tricky question. You have to analyze it a bit. Try to analyze. Try to analyze this. After getting the answer, you have to analyze it a bit. Try to analyze it. First you get the answer and then try to analyze it. First you get the answer and then analyze it. What is the answer you got? So A is going to give us A star and B is going to give us A star. So the language is A or B, which means A star plus A star, right? Now this is multiple of 2, this is multiple of 4. And multiple of 4 will be covered by multiple of 2. Therefore, you don't have to write both of them. The answer is A star. Okay. This is multiple of 4, this is multiple of 2. You don't have to write multiple of 4 separately because multiple of 4 is covered by multiple of 2, right? Therefore, A star is the answer. A star is the answer. Okay. Now give the grammar for A star, B star. Any grammar. Okay. Give me context free grammar or regular grammar or both. Okay. A star, B star. Write it on the paper and post it in the Telegram channel. Okay. Write it on a poster and post it on Telegram channel. A star, B star. You can give context free grammar or you can give regular grammar or you can give both. Write your answer and post it on the Telegram channel. A star, B star. Okay. So you can give the context free grammar easily, generate A star, B star separately and put them side by side. Okay. Generate A star A derives AA or epsilon, generate B star, B derives BB or epsilon. So A star and B star are generated. Now you put them side by side. S derives AB. So it is going to give you A star B star, but this is context free grammar because two variables are side by side here. This is context free grammar. Okay. Now how to use the regular grammar? So I can use the regular grammar like this. S derives AS or A. S derives AS or A. A derives BA or epsilon. A derives BA or epsilon, right? So this is the right linear grammar. This is the right linear grammar, right? Now if you want to generate epsilon, you can generate epsilon. If you want to generate A star, you can generate A star. If you want to generate B star, you can generate B star. If you want to generate AB star, you can generate AB star. Right? So A star is generated, B star is generated, A star, B star is generated, and also epsilon is generated, right? Right? So this is the right linear grammar for A star, B star. Right linear grammar for A star, B star. Now generate the right linear and left linear grammar for A plus B star. A plus B star. Generate right linear and left linear grammar for A plus B star. You can use context free grammar also. Give some grammar. Context free grammar and regular grammar. Context free grammar and regular grammar. A plus B star. Okay. So let's see the context free grammar for this. S derives A or B or SS or epsilon. This is the context free grammar, right? Why? Because two S's are side by side, it cannot be regular. Okay. Now what about regular grammar? S derives AS or BS or epsilon, or S derives SA or SB or epsilon. These are regular grammars. This is context free grammar, right? And one thing you have to one small thing that you can make an observation is, whenever SS or epsilon is there, the grammar is ambiguous. Whenever SS or epsilon is there, the grammar is ambiguous, because there are multiple ways you can generate epsilon, right? You can directly generate epsilon like this, S0 as epsilon, or you can generate epsilon like this, SS, epsilon and epsilon, right? Or you can generate epsilon like this, right? So for one string, more than one parse tree is possible, therefore the grammar is ambiguous. Therefore the grammar is ambiguous, right? Right? Now A and B can be anything. Now let us say L is something. L can be anything. L can be any string. Now if you want to put L star, what is the grammar? If you want to put L star, what is the grammar? If you want to put L star, what is the grammar? L can be anything. If you want to put L star, what is the grammar? So if you want to put a star to anything, you can write like this. S derives LS or epsilon. This is going to put a star. You can generate any number of L's. You can generate any number of L's, right? So if L equal to A plus B, then what happens? S derives A plus B, S or epsilon, right? Now if you expand it, you are going to get S derives AS or BS or epsilon. S derives AS or BS or epsilon, right? Right? Okay. Answer this question. 0, 0 plus 110 star. Give the grammars. You can give context-free grammar, you can give regular grammar. You can give context-free grammar, you can give regular grammars. You can give context-free grammar, you can give regular grammars. Zero zero plus 110 star. Zero zero plus 110 star, right? So you can give a grammar like this. S derive 00 or 110 SS or epsilon. Whenever you have SS or epsilon, it is ambiguous grammar. Okay, fine. And this is not a regular grammar because SS are side by side, two variables are side by side. So this is not a context-free grammar. So this is a context-free grammar, right? Now what is the regular grammar? S derives 00S or 110 110S or epsilon. This is right linear grammar, right? What is the left linear grammar? S derives S followed by 00 or S followed by 110 or epsilon. This is left linear grammar. This is left linear grammar. Okay. Answer for this: A plus B plus. A plus B power plus. Give the context-free grammar and regular grammars. Give the context-free grammar and regular grammars. A plus B plus, right? Very good, Janardhan. So you can write a simple context-free grammar like this: S derives A or B or SS, right? Now if you try to give the regular grammar is going to be S derives AS or BS or A or B. Similarly, right linear grammar is going to be S derives SA or SB or A or B, right? Now this is the context-free grammar. These two are regular grammars. This is right linear grammar. This is left linear grammar, right? Now whenever you get SS, just be careful. The grammar is ambiguous, right? Now if I have to generate A using this grammar, then I have two parse trees. S derives SS, SS, S derives SS, SS, A, 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 right? So whenever you have SS, the grammar, there are chances that the grammar is ambiguous, right? Now tell me about this. What does this grammar generate? S derives AS or SB or epsilon. S derives AS or SB or epsilon. S derives AS or SB or epsilon. What is the language generated? S derives AS or SB or epsilon. S derives AS or SB or epsilon. S derives AS, SB or epsilon, right? So try to generate these strings and you see what is the language generated. Okay. So S can derive epsilon or S can derive A star or S can derive B star or S can derive AS, AS, SB, SB, AS, epsilon, which means S can derive B star followed by A star. A star followed by B star. Therefore, the language generated is A star, B star. The language generated is A star, B star. We have seen the finite automata also for this A star, B star. Right? Right? Now tell me about this. S derives ABS or SBA or epsilon. S derives ABS or SBA or epsilon. What is the language generated? ABS or SBA or epsilon. Try to generate these strings, then you will be able to answer it. Okay? Generate these strings. Try to generate these strings, then you will be able to answer it. It is similar to the previous grammar, right? Very good, Janardhan. It is similar to the previous grammar, right? So S derives ABS, S derives ABS, or S derives SBA, S derives SBA or epsilon. So if you see this, this is AB star followed by BA star. This is AB star followed by BA star. AB star followed by BA star, right? Now tell me about this. S derives AS or SB or C. 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 Try to generate these strings and see the answer, okay? Try to generate these strings and see what you are getting. Try to generate these strings and see what you are getting. S0 is AS, S0 is AS, S0 is SB, S0 is SB or C, right? Now if you observe it, this is A star followed by C followed by B star. A star followed by C followed by B star. A star followed by B followed by B star. Answer this question. S derives XS or YS or Z. What is the language generated by this? S derives XS or YS or Z. What is the language generated by this? S derives SX or YX, YS or C or Z. S derives Sx or Ys or Z. So try to draw the language, then you will understand. Okay. So S derives Xs, Ys, Xs or Z. Right. So if you observe it, you are getting X plus Y star followed by Z. X plus Y star followed by Z. X plus Y star followed by Z. Right? Answer this question. S derives Sx or Sy or Z. S derives Sx or Sy or Z. Answer this question. S derives Sx or Sy or Z. What is the language generated? S derives Sx or Sy or Z. Draw the strings, you will be able to answer it. Draw the strings, you will be able to answer it. Right. S derives Sx, Sy, Sx, Z. If you see this, this is Z followed by X plus Y star. This is Z followed by X plus Y star. Right. Answer this question. S derives 0, 1s or S10 or 11. S derives 0, 1s or S10 or 11. S derives 0, 1 or S10 or 11. S derives 0 1 S or S1 0 or 1 1. Okay. S derives 0 1 S, S1 0, 0 1 S, S1 0 or 1 1. Very good, Janardhan. Your answer is right. Right? So, what is it? 0 1 star followed by 1 1 followed by 1 0 star. 0 1 star followed by 1 1 followed by 1 0 star followed by 1 0 star. Right? Now, if I say L equal to A comma B, that's it. Nothing. Then what is the grammar? S derives A or B. Now if I say L equal to strings of length 2, A plus B, A plus B. L equal to strings of length 2, A plus B, A plus B. L equal to strings of length 2, A plus B, A plus B. Now what is the language? S derives A. This is context-free language. A or B. This is context-free language. Now what is the regular language for this? Regular grammar for this? S derives A or BA. A derives A or B. This is the right linear grammar, regular grammar. This is the right linear grammar, right? Now give the context-free grammar for this. No need to give the regular grammar. String lengths of at least 2. String lengths of at least 2, which means A plus B, A plus B, A plus B star. String length of at least 2. Try to give the answer. String length of at least 2. First you generate a plus b, and then you generate a plus b star. Okay, so a plus b can be generated like this. B derives a or b. A plus b star can be generated like this. A derives a, ba or epsilon. So this is a plus b, this is a plus b star. Now S derives a plus b followed by a plus b followed by a plus b star. This is not regular. We will see regular grammar later. Okay. Now answer this question. String length is at most 2. String length is at most 2. What is the regular expression for this? A plus b plus epsilon. A plus b plus epsilon. Right? Generate the context free grammar for this. No need of regular. We'll see regular later. Okay. A plus b, epsilon. String length is at most 2. A plus b plus epsilon. A plus b plus epsilon. So first generate a plus b plus epsilon, right? So how are you going to answer this? First generate a plus b plus epsilon and a plus b plus epsilon. A derives a or b or epsilon, right? Now you have to put two a's. This is a, this is a. Both of them side by side. That's it. Both of them side by side. That's it. Okay. Now starting with a and ending with b. Starting with a and ending with b. Right? String starting with a and ending with b. सौम्या ए ईयर का क्रैश कोर्स और भी अच्छा होगा. ए ईयर का क्रैश कोर्स करना. ठीक है. डू दी क्रैश कोर्स ऑफ दिस ईयर. starting with A and ending with B. Starting with A and ending with B. So the language is A plus B star B, starting with A and ending with B, right? So you have to generate A plus B star. S derives A, B. A has to be A plus B star, right? Now A is going to be A or A, BA or epsilon. A or BA or epsilon. This is non-regular grammar because A is present in between, right? If it has to be regular grammar, the variable has to be present either at the right end or at the left end. Okay. So this is starting and ending with A and ending with B. Starting with A and ending with B, right? Now starting and ending with different symbols. 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 So if it is going to start with A, it has to end with B, right? Or if it is going to start with B, it has to end with A, right? So S derives starting with A plus B star B, or starting with B, A plus B star A, right? Now what is A? A is A plus B star. AA or BA, AA or BA or epsilon. AA or BA or epsilon, right? In between we are putting A plus B star. In between we are putting A plus B star, right? Now I'll give you a language which is non-regular. A power n, B power n such that n is greater than or equal to 1. This language is non-regular. Why is it non-regular? The reason is finite automata cannot do comparison, right? Can you give a grammar for this? Can you give a grammar for this? A power n, B power n. Give a context free grammar. You cannot give regular grammar because this is not a regular language. Okay. या सौम्या फिर से इस साल का कर सकते हो, ठीक है? हमें क्रैश कोर्स हम पूरा करते हैं तो फुल मार्क्स आएगा क्रैश कोर्स से भी, ठीक है। क्रैश कोर्स में भी हम पूरा कोर्स करते हैं तो फुल मार्क्स आएगा क्रैश कोर्स में। तो a पावर n b पावर n, राइट। So a power n b power n is not equal to a star b star, Janardhan. A star b star means any number of a's and any number of b's, but here a's and b's have to be equal, right? So the grammar is going to be whenever you generate a generate a b, or simply generate a b, right? Now what is it going to be? S derives a as b, which means equal number of a's and b's. Again S derives a as b, equal number of a's and b. S derives a b, right? Right. So equal number of a's and equal number of b's. This is not a star b star, Janardhan. Okay. Tell me about this. Sigma equal to a comma b. Sigma equal to a comma b. L equal to w power r, which means even length palindrome, union wr, which means odd length palindrome with a in the middle, union wr. So this language is not regular because comparison is required. If w equal to ab, then wr will be ba. So this is a palindrome, right? Read from here or read from here, it will be same, right? So if w equal to ab, then there is a in between, then ba, right? Palindrome. Now if w equal to ab, middle there is b, then ba. Read it here or here, this is palindrome. Now this is not a regular language. Try to give the context free grammar for this. Try to give the context free grammar for this. Okay. This is not a regular language. This is not a regular language. Try to give the context free grammar for this. This is not a regular language. Try to give the context free grammar for this. So if starting A is generated, ending A has to be generated. If B is generated, B has to be generated, right? So if A is generated in the starting, A has to be generated in the ending. If B is generated in the starting, B has to be generated in the ending, or it can be simply A or simply B, or because W belong to sigma star, which means W can be epsilon also, right? A or B or epsilon, A or B or epsilon, right? Now let's see even length strings. A plus B, A plus B star. This is even length strings. A plus B, A plus B star. This is even length strings. Okay. This is regular, but give the context free grammar. We will see regular grammar later. We will see how to convert a finite automata to regular grammar. Soumya, while revising, take a book and try to solve the problems. Okay. Just don't read them. Try them on a paper. Even length strings. A plus B, A plus B star. Even length strings. Yes, Soumya, you can solve PYQs. A plus B, A plus B star. A plus B star, even length strings. Right? A plus B star. So first you generate star. A derives Bs or epsilon. Now what is B? B is A plus B, right? So this is going to generate B star. Now B is going to be A plus B, which means B is going to be A. Now A is going to be A or B. A is going to be A or B, right? Now answer this question. A power n, B power m, A power n, B power m, such that n comma m greater than or equal to 1. N comma m greater than or equal to 1. A power n, B power m, such that n comma m greater than or equal to 1. A power n, B power m, such that m comma n greater than or equal to 1. We have done a similar model earlier also. Try doing this. We have done a similar model earlier also. Try doing this. Right? A power n, B power n, such that m comma n greater than or equal to 1. So this is A plus B plus. This is A plus B plus. right? So you are going to generate A plus, A derives AA or A. You are going to generate B plus, B derives BB or B. These are going to be A plus and B plus. Put them side by side. A plus followed by B plus. Put them side by side. Put them side by side, right? Or one other way is S derives AS or SB or AB. Now if you observe it, S derives AS, S derives AS, S derives SB, S derives AB. Now you can get any number of A's followed by any number of B's. So this is also a grammar which is not regular grammar. These two are not regular grammars. These two are context-free grammars. Earlier we have seen regular grammar, right? Now tell me about this. A power n, B power n, C power m such that n comma m greater than or equal to 1. A's and B should be equal. C's can be any number. A's and B should be equal. C's can be any number. ठीक है? हमें PYQ के बुक लेके सॉल्व करना, ओके? रिवीजन करने के बाद PYQs को सॉल्व करना. A's and B's have to be equal and C's can be any number. A's and B's have to be equal and C's can be any number. A's and B's have to be equal and C's can be any number. Right? So first generate equal number of A's and B's. First you generate equal number of A's and B's. A derives AA or AB or AB. This will generate equal number of A's and B's and generate any number of C's, C, C or C. This will generate any number of C's. Then you just put them side by side, equal number of A's and B's followed by any number of C's. Equal number of A's and B's followed by any number of C's. Right? Now answer this question. A power n, B power m, C power n such that n comma m greater than or equal to 1. This language is also not regular. The reason is comparison is required between A and C. Comparison is required between A and C. Let's change the language. A power n, C power m, B power n. Comparison is required between A and B, right? C can be any number. N comma m greater than or equal to 1. Comparison is required between A and B, and C's can be any number. C's can be any number. Okay? Comparison is required between A and B. C's can be any number. Post your answer on the Telegram channel. Post your answer on the Telegram channel. Okay? Beetroot, huh? Beetroot, huh? Okay. So generate A's and B's. Whenever A is generated, B is generated, right? Right? And you generate C's separately. Generate C's separately, right? And you put C's in between, right? A, B, A, B, right? Now tell me about this. a power n, b power n, c power m, d power m such that m comma m greater than or equal to 1. This language is not regular. This language is not regular because comparison is required here, comparison is required here. This language is not regular. Try to give the context-free grammar for this. Try to give the context-free grammar for this. The language is not regular. You cannot give regular grammar for this. Give the context-free grammar. A power n, b power n, c power m, d power m, right? So separately generate a power n, b power n, c power m, d power m and put them together, right? So a derives a b or a b. So this is going to generate a power m, b power m, right? This is going to generate a power m, b power m. Now you generate c power m, d power m, right? B derives c, b, d or cd. Now you put them side by side. S derives ab. So this is the context-free grammar for the given language. This is the context-free grammar for the given language. Okay. Try to answer this. A power n, b power n, c power n, such that n is greater than or equal to 1. This language is not regular. Comparison is required. This language is not regular. Right? Answer this. Naindeep, later I will tell you how to identify regular languages. Okay. So this language is not regular because comparison is not required, and this language is not context free also. This language is not regular. This language is not context free language. This language is context sensitive language, right? So you cannot give a context free grammar for this, and context sensitive grammar will be very complex, that will not be asked in exam. That will not be asked in exam. Answer this: a power n b power 2n such that n is greater than or equal to 1. A power n b power 2n such that n is greater than or equal to 1. A power n b power 2n such that n is greater than or equal to 1. Thank you, Parisha. A power n b power 2n such that n is greater than or equal to 1. Thank you, Parisha. Okay. So for every A, you have to generate 2 Bs. For every A, you have to generate 2 Bs. S derives ASBB. For every A, you have to generate 2 Bs. Or S derives ABB, right? Answer this question: A power n, B power m, C power m, D power n, such that n comma m greater than or equal to 1. This language is not regular. You cannot give regular language grammar because comparisons are required. You can give context free grammar for this. You can give context free grammar for this. Okay. You can give context free grammar for this. A power n, B power m, C power m, D power m. A's and D's have to be equal, B's and C's have to be equal. A's and B's have to be equal. A's and D's have to be equal, B's and C's have to be equal. Okay. Okay. So what is the answer you got? A's and C's have to be same, and B's and C's, A's and D's have to be same, and B's and C's have to be same, right? Generate A's and D's together and generate B's and C's together. B's and C's together, right? When you stop generating, when you are done generating A's and D's, then you generate B's and D's, B's and C's, right? So you are going to write A, D, right? Why are you not writing simply A? Because minimum string is A, B, C, D. So AB has to be generated, otherwise only BC will be generated. Okay. Now answer this question. A power m plus n, B power m, C power n, B power m, C power n such that n comma m greater than or equal to 1. M comma n greater than or equal to 1. What is the answer? A power m plus n, b power m, c power n. So you are going to write it as a power n, a power m, b power m, c power n, n comma m greater than or equal to 1. Right. Now you have to generate a's and c's together, and a's and b's you have to keep them in between. Right. So first you generate a's and c's together. ASC or then generate A's and B's together. A derives AB or AB. Now you put A in between A's and C's. Between A's and C's you put A, right? So you are going to write AAC, AAC, right? Now answer this question. A power n, B power n plus m, C power m such that n comma m greater than or equal to 1. M comma n greater than or equal to 1. What is the answer? You need to expand it. Okay? You need to expand it. You need to write it as a power n, b power n, b power m, c power m, n comma m greater than or equal to 1. Generate a's and b's together, generate b's and c's together, and put them side by side. Generate a's and b's, a, b, or a, b. Generate b's and c's. B derives B, B, C, or B, C. Now you put them together. A derives AB. A derives AB. Right? Now answer this question. A power n, B power m, C power m plus n such that n comma m greater than or equal to 1. M comma n greater than or equal to 1. This is not regular. Comparisons are required. This is not a regular language. Comparisons are required. This is not a regular language because comparisons are required. Give the context free grammar for this. Okay. Expand it and try to do this. Expand it and do it. Okay. So how are you going to solve this? How are you going to solve this? You are going to expand it like this. A power n, B power n, C power m, p power n such that n comma m greater than or equal to 1. Right? Right? So generate A's and C's together, and in between you put B's and C's by generating them together, right? So first you generate A's and C's together and generate B's and C's together and generate B's and C's together. Now in between A's and C's you put B's and C's. A, C, right? Now I'll give you a difficult question. This question is going to be difficult to answer, but try this. What is the language generated by the following grammar? What is the language generated by the following grammar? S derives AA or BS or epsilon. A derives AB or BA. B derives. This is a difficult question. Take time and answer it. BB. What is the language generated by this grammar? What is the language generated by this grammar? This question is difficult. Take time and try it. This question is difficult. Take time and do it. What is the language generated? Okay, so it is very difficult to answer this question directly. So what you can do is you can convert this right linear grammar into a finite automata, right? You can convert the right linear grammar into finite automata. So state S has epsilon, therefore S is final state. Wherever there is epsilon, you can write it as final state. Okay. On A, it is going to state capital A. On B, it is going to S. And state A on small a is going to state B. State A on small a is going to state B, and on small b is going to A only. And state B on small a is going to S, on small a is going to S, and on small b is going to B only. And on small b, it is going to B only, right? So if you observe it, this is number of A's are divisible by 3, right? Number of A's divisible by 3. Number of A's divisible by 3, right? So you can convert a right linear grammar to a finite automata. You can convert a right linear grammar to a finite automata, right? Right? Okay. We'll take a small break for 3 minutes. After that, we'll continue. Okay. We'll take a short break for 3 minutes. After that, we'll continue. We'll see rules to convert right linear grammar to finite automata. We will see rules to convert right linear grammar to finite automata. So let's now see the rules to convert. Let's now see the rules to convert right linear grammar to finite automata. Right? If I have A derives epsilon, it means that A is final state. If I have A derives epsilon, it means that A is final state. If I have A derives small a, then you are going to add a state like this, and this is going to be final state. Right? Right? If I have A derives AB, then you are going to add two states AB final state. Right? If I have S derives AAB, then I am going to add three states S, A, A, B, A, B. Right? If I have S derives A, B, then I am going to write it like this. S derives A, A, B. B is not a final state. B is not a final state. Right? Now I'll give you a question that is a little bit difficult. Try to answer this. I'll give you a question. It is a little bit difficult. Try to answer this. What is the language accepted by the following grammar? What is the language? S derives AA or BC. A derives AS or BB or epsilon. B derives AC or BA. C derives AB or BS. AB or BS. Okay. What is the language accepted by this regular grammar, which is right linear grammar? What is the language accepted by this right linear grammar? What is the language accepted by this right linear grammar? Try this. This is one of the difficult questions. You will not be able to solve it directly. I will tell you the method, but you try answering this. Okay. What is the language accepted by this grammar? Okay. So what is the answer for this? You cannot do it directly. You have to convert it to finite automata, right? You have to convert it to finite automata, right? So S is a state. S on small a is going to capital A, right? And S on small b is going to capital C, state C, right? A on small a is going to S, and on B it is going to B, and on B it is going to B, right? and A derives epsilon, therefore A is final state. A is final state. And B on small a is going to C, and small b is going to A, and C on small a is going to B, and on small b it is going to S, right? So this is the finite automata, right? Now A is the final state. What will you do if A is the final state? How do you find out the language? How do you find out the language, right? Draw two lines with A as intersection, and those two lines will give you the answer, right? So this horizontal line, A's can be anything, but B's are always even number of B's, even number of B's. And this vertical line, B's can be anything, but A's are odd. A's are odd. Therefore, the answer is even B's, and odd A's. Even B's and odd A's. Even B's and odd A's. Right? This is how you convert a right linear grammar to a finite automata. This is how you convert a right linear grammar to a finite automata. This is how you convert right linear grammar to a finite automata. Now, how to convert a left linear grammar to a finite automata? How to convert a left linear grammar to a finite automata? Let us say a left linear grammar is given and the language represented by this is L. Now you reverse the productions. Then you get right linear grammar and the language will be reversed. And for this right linear grammar, you give the finite automata and the language will be L power R reversal, right? And you reverse the finite automata. Then you are going to get the language L power R, which is equal to L, which means we have converted left linear grammar to finite automata, but this is a long procedure. Generally, questions will not be asked on this. Okay. Now let us see how to convert a finite automata to a left linear grammar. Okay. So try this. This is the finite automata. Convert this into left linear grammar. This is a finite automata. Convert this to left linear grammar. This is a finite automata. Convert this to left linear grammar. Given a finite automata, getting right linear grammar is easy, but converting it to left linear grammar is not so straightforward. Converting it to left linear grammar is not so straightforward. Try to convert the finite automata to left linear grammar, right? So how are you going to convert the finite automata to left linear? Now reverse the finite automata, okay? Reverse the finite automata representing language L power R. Now let us say this is state A, this is state B. How do I reverse the finite automata? Make the final state as non-final state and make the final state as initial state and initial state as final state, right? So what do we get? Initial state is made as final state and final state is made as initial state, right? Final state is made as initial state and reverse the transitions right? Now for this finite automata representing L power R, give the right linear grammar. Now this right linear grammar will represent L power R. Now what is the right linear grammar for this? B on seeing A is going to B, on seeing B is going to B, and then on seeing A is going to A, and A is the final state, not having any transitions, therefore A derives epsilon. Now for this right linear grammar, do left linear grammar by reversing the productions. Reverse the productions and do left linear grammar. Reverse the productions and do left linear grammar. Right linear grammar is generating L power R. Now left linear grammar will generate L power R, which will be equal to L, right? Now you reverse it. You reverse the grammar. Then what do I get? B derives BA or BB or AA. A derives epsilon. A derives epsilon. A derives epsilon. Right? Right? Now let us see various algorithms in regular languages. Algorithms in regular languages. Algorithms in regular languages. One algorithm is converting NFA to DFA, and other algorithm is converting DFA to minimal DFA, converting DFA to minimal DFA, and other algorithm is converting epsilon NFA to NFA, converting epsilon NFA to NFA, and other algorithm is converting Mealy machine to Moore machine, and other algorithm is converting Moore machine to Mealy machine. Okay? So we have all these five algorithms. We are going to discuss all of these algorithms. Okay. Currently you don't know what is Mealy and Moore machine. We'll discuss them later. Now first let's do NFA to DFA. NFA to DFA conversion. Now let's do NFA to DFA conversion. Okay. Let us say we have a NFA like this. Q0 is the initial state. Q0 is the initial state. On A, it is going to Q0 and Q2. On B, it is not going anywhere. And coming to Q1, it is going to Q2 and Q1. Coming to Q2, it is going to Q0 and Q1. Q0 and Q1, right? Now construct a DFA for this. Construct a DFA for this. You try this, I'll explain it, okay? You try this, I will explain it. You try this, I'll explain it. Okay. Convert the NFA to DFA. Okay, I will explain this. See this. So don't write the entire table in DFA. Just take the first row. You just take the first row. Okay. So Q naught is a single state, is going to Q0 Q1 Q2. Now we are making Q0 Q2 as a single state. Even though ये दो स्टेट्स है, फिर भी हम Q0 Q1 को सिंगल स्टेट बना रहा है. ठीक है. एंड जहां पे भी डैश होगा उधर डेड स्टेट लगा देंगे और डेड स्टेट ए और बी में डेड स्टेट ही जाएगा. ठीक है. अभी Q0 Q2 नया स्टेट बना है, ठीक है। तो सिर्फ पहले रो को लिखना और रो में डैश है तो डेड स्टेट डाल दिया। अभी नया स्टेट क्या आया, Q0 Q2 आया, ठीक है। तो Q0 Q2 को हम ऐड करेंगे DFA में, ठीक है। तो Q0 Q2 और डेड स्टेट दोनों कंप्लीट हो गया, डेड स्टेट कंप्लीट हो गया। अभी Q0 Q2 करेंगे, ठीक है। तो Q0 Q2 का यूनियन लेना इधर से, ये पे यूनियन क्या है, Q0 Q2 है, ठीक है। ये पे यूनियन है Q0 Q2, ए पे यूनियन है Q0 Q2 और बी पे यूनियन करेंगे तो Q1 आएगा, ठीक है। तो ऑलरेडी Q0 Q2 कंप्लीटेड है, अभी Q1 को लेंगे, ठीक है। अभी Q1 को लेंगे तो Q1 क्या कहाँ पे जा रहा है, Q2 Q1 पे जा रहा है, Q1 जा रहा है Q2 Q1 पे, ठीक है। और Q1 तो ऑलरेडी कंप्लीटेड है, तो अभी Q2 को लेंगे, अभी Q2 को लेंगे। तो Q2 कहाँ पे जा रहा है, Q0 Q1 पे जा रहा है, Q2 जा रहा है Q0 Q1 पे, ठीक है। और Q0 ऑलरेडी कंप्लीटेड है, Q1 ऑलरेडी कंप्लीटेड है, तो सारा स्टेट्स कंप्लीटेड है, सारा स्टेट्स कंप्लीटेड है। तो फाइनल स्टेट क्या होगा, जहां पे भी इधर फाइनल स्टेट Q1 है ना, इधर जहां पे भी Q1 है वो फाइनल स्टेट बनेगा, ठीक है। हाँ शांतनु, कंपाइलर डिजाइन का क्रैश कोर्स भी डिजाइन है। तो Q1 फाइनल स्टेट होगा, Q1 फाइनल स्टेट होगा, ऐसा करेंगे NFA टू DFA, ठीक है। तो आज का क्लास इधर एंड करते हैं, कल और भी एग्जांपल्स देखेंगे, ठीक है। थैंक यू एंड जय हिंद, थैंक यू एंड जय हिंद।